Good day, everyone. Today I'll be taking you guys on mathematics on the topic as seen on the board, algebraic fractions. Algebraic fractions are simply fractions that has a top term and equally a bottom term. Or also it can also have a top expression or a bottom expression. For instance, if I have A over B, prove that B is not equal to 0, B is an expression. Because if B equals 0, then the expression will be undefined. Because any expression at the top divided by 0 gives you an undefined fraction. So in algebraic fraction, the first I'll start with is simplification. Let me write it first. To simplify an algebraic fraction simply means to make the fraction given to look easier or to look what more simpler. For example, if I have 2x minus 4 all over, let me say 4 minus 8x. This simply gives me an expression of this kind because 2 is common at the numerator. I'll simply have 2 bracket x minus 2 and also 4 bracket 1 minus 2x. Remember, if I expand, I'll have 2x, and if I expand 2 and 2, I also have what? 4. And if I multiply 4 by 1, I'll have 4, and I'll have, if I multiply 4 and 2x, I'll have what? 8x. By this, you can see we can cancel this and this, giving us x minus 2 all over 2 brackets 1 minus 2x. This is a simplified expression of 2x minus 4 all over 4 minus 8x. And if we assume x to be any value, provided that it won't give the denominator to be equal to 0, the expression, and the main expression and the final expression will be exactly what? Equal. So let me give a further example from our textbook. Let's see this example 1. If I have m nu all over nuv, and I'm asked to simplify, all I need to do is simply to break down or cancel out the top and the bottom values that are what? Common. Call the common what? Factors. This simply gives me m nu all over nuv. We can see that n can cancel n and u can cancel u. And our final answer will be m all over what? V. And we also have another example here. That's 8x squared z all over 10xyz. If we have this, we simply see that 2 is common for the numerical values 8 and 10. What we simply do here is that since 2 is common, we simply say 2 times 4 times x times z all over 2 times 5 times x times y times z. So 2 simply cancels 2, s cancels x, and z cancels z. We are left with 4 and x at the numerator, giving us what? 4x. And we have 5y at the denominator, giving us what? 5y. So this is a simplified expression for this expression given. So that's for that. Let's move to another example. Please note that we are moving from simpler example to difficult ones. Please help me to erase the board. So we have another example here. We have u square minus uv all over uv plus v square. If we have this, you simply understand that at the numerator u is common. And remember, we pick the smaller value. U square is greater than u, so we pick u. So if we have u, we have bracket, u square divided by u gives you what? U. And uv divided by u gives us what? V. All over At the denominator, which is the bottom value, the bottom expression, we have the highest power as v squared and the least as v. So we take the smaller value, which is v. And uv divided by v gives us u plus, and we have v squared. V squared divided by v gives us what? V. So we have this, and nothing can simplify this further. So we simply leave it that way. So I'll try to make the questions we are solving to be a little bit more complex. So we have another example. We have c squared minus 2c minus 15 all over c squared minus 2cs minus 15 all over c squared minus 3c minus 10. So having this, we simply see this is more difficult compared to the previous examples. We can see that this is more difficult than the other examples. So what we need to do here is to try to factorize, because the numerator and the denominator are quadratic in nature. So how do we factorize? We can see that the constant at the coefficient of s squared is simply what? 5, 15, and what? 1. And 15 times 1 gives us 15. And there's no way 15 and 1 combined will give you negative 2c. So we'll do a long division for 15. 2 cannot divide. 3 into 15 gives you what? 5. And 5 is a prime number, so 5 must divide itself to give you what? 1. And 3 times 5 is equivalent to what? 15. If I say 3c minus 5c will give me 2c, negative 2c, which equals this. And we focus on the denominator as well. 10 times the coefficient of c squared will give you what? 10. And 1 and 10. 1 and 10 can never give you what? Minus 3c. So we'll do a long division for 10 also. It's easier this way, trust me. 2 can go 5, and 5 can go 1, giving you 2 and 5. So 2 times 5 is equivalent to the 10 we have at the top. So the product of the roots remain what? 10. So how can we use 2 and 5 to get negative 3? If I say 2c minus 3c, this is like 2 minus 3. If I say 2c rather minus 5c, this will give me what? Negative 3. So I'll attach my c, gives me negative 3. So the top expression becomes c squared plus 3c minus 5c minus what? 15, all divided by c squared minus 3c will be replaced by 2c minus 5c, which is plus 2c minus 5c, and we have our negative what? 10. Now, our last two terms, visible terms, when you multiply them, it must equal this first term as seen here. Negative negative gives you what? Positive. And negative negative here also gives you what? Positive. Then we try to group the top and group the bottom. Grouping the top, we have the first two terms as what? C squared plus what? 3c. We enclose it. The middle term comes exactly the way it is. And we enclose the last two terms, 15. But when the negative term is at the outside of a bracket, we simply change the terms inside. So negative 5c here become positive 5c, and negative 15 become positive what? 15. Check. Negative times invisible positive 5c gives you negative 5c, and negative times positive 15 gives you what? Negative 15c. And also another check, the sign inside and here should be what? The same to a great extent. We'll see an example whereby likely these two terms will be different, and there's how we'll deal with it. Now we focus at the denominator. We have our c squared plus 2c in brackets. Negative come exactly the way it is. And yet instead of negative 5c, we have what? Positive 5c. And instead of negative 10, we have what? Positive 10. Again, check. Negative times invisible positive is negative, and negative times positive is what? Negative. Now, in this bracket, we can see that c is common. We take the smaller one. We can't take c squared s. We have a fraction here. So we simply have c. C divided by c squared gives you what? C. Put your positive sign. 3c divided by c gives you what? 3. Check. C times c, c squared. C times 3, 3c. Minus, what's common here is 5. Simply, I have 5. 5c divided by the 5 that is common gives you what? C. 15 divided by 5 gives you what? 3. You can see that the two brackets at the numerator are what? The same. Now, we'll do the same at the denominator. C is common between c squared and 2c. I'll bring my c at c squared divided by c, and 2c divided by c gives you what? 2. Minus 5 is common here. I have 5, bracket 5c divided by 5 gives you c, and 10 divided by 5 gives you what? 2. Again, the two brackets are what? Same. So we pick this, combine with this and the sign, and we pick one of the two brackets since they are same. And we also pick this c together with the negative 5 and one of these. So we simply have c minus 5 and what? C plus what? 3. All divided by c minus 5, bracket what? C plus 2. So you see that c can cancel c, and our final answer here will give me c plus 3 all over c plus what? 2. Thank you. So let's see our next question. So we have a question here which says m cube n minus 2m square n square all over 2mn cube minus m square n square. So how do we resolve this? If you follow the same process, trust me, you are going to get the answer like we've been getting. First, you try to look at the numerator to see what's common. Remember, this first subtopic has to do with simplification of fractions. So you can see that the top expression have something in common. They have m squared in common, and they also have n in common. Let me prove it to you. Since this is m squared, I can simply say m squared n minus 2 m squared n. M squared times m will give me m cubed, and n times n will give me what? N squared. I'm doing it to be easy so that it will be easier for us. All over, what's common here? 2 is not common, m is common. So I'll write my words 2m, this is n squared, this is n cubed. So I can reduce this to n squared n minus m n squared. Now you see, at the top, m squared is visible, that is so common. So we simply have what? M come before n. So I'll have my m squared n. And if this expression is being divided by this, I'll have m left. I'll put my negative sign. If I have this being divided by this, m squared will cancel m squared, n will cancel m, and I'll have what? 2n left. At the bottom, and if you check, m squared n times m will give you m cubed n, like we have here. And m squared n times 2n will give 2m squared n squared, like we have here. So we'll do the same at the denominator. What's common? M is common, and n squared is common. So I'll write my m and my what? N squared. If these two divides, I'll have what? 2m left, meaning mn squared have divided with mn squared. And also, if mn squared divide this, I'll have m left. Now I can cancel out. This can cancel this square at the top, and I'll have m here. And this, meaning nn, can cancel one of these, and I'll have what? And I'll have what? N here, in brackets. Now, if you watch these two, I can rearrange inside. Rearranging is not crossing over to the other side of the equation, because this inner bracket is just an expression. So therefore, I'm only rearranging and the sign remains the same. So negative 2n remains negative 2n. There's an invisible plus attached to this n. So I have my plus what? M. All over, this remains the same. Here ought to be n. So we have our 2n minus what? M. Let me try to manage this space. This remains m over n in brackets. Now, if you watch, why here is negative 2n, here is positive 2n. Why here is positive m, here is negative m. If I should put two negative signs at the top, it does not change anything. Because minus minus will still give me what? Plus. So I'll have my 2mn plus m all over 2n minus what? M. So continuing from where we stop, I can simply use one of the negative sign rather, to multiply the top expression or the bottom expression, so the two will look alike, will be exactly the same. Now one of the negative multiplying this negative 2m will give me positive 2n. And this same one negative times this positive sign will give me negative, and I'll have my m. We still have one negative sign left, remember. And this become n bracket 2n minus what? M. Now you see, this can simply cancel this, and I'll have negative m over n as my final what? Answer. Let's move on to the next example. So, let's try this. If I have u squared minus 5uv plus 6v squared all over u squared plus uv minus 12v squared. If I have this, the first thing I have to do, since this is square and this is square, I have to focus on the coefficient of the v square, which is 6, and the coefficient of the u square, which is 1. And I have my 6 times 1 to be equals to 6. You can simply want to say 1 minus 6 will give me negative 5. But I prefer the XCM. 2 can go, I'll have what? 3, and 3 can go, I'll have what? 1. So I'm using 2 and what? 3 as my products. And you can see that minus 2u minus 3u will be equal to minus 5, uv. Minus 5 what? uv. So I'm going to be replacing my minus 5uv with minus 2uv minus 3uv. And also at the denominator, I have 12 times invisible 1, which is equals to 12. I can't use 12 and 1 to have uv. uv is same as 1 uv, but you can't see 1 together with a 10. So therefore, I'll say 12. 2 into 12 will give me what? 6. 2 into 6 will give me 3. And 3 into 3, since 3 is a prime number, gives me 1. Now I can't have 3 terms. I have to combine two of the terms to be 1, and 1 will be on its own. So I can simply say 2 and 2 will give me what? 4 as product, and what? 3. 4 times 3 will also give me what? 12. And if I should say 4uv minus 3uv, I will have 1uv. I'll clean my 1 for your understanding, because there's nothing like 1uv. uv is the same as 1uv, being a mathematician. So therefore, fixing the terms which I just derived, I will have my u squared. In place of minus 5uv, remember we are using minus 2uv minus 3uv, and I'll have my what? Plus 6v squared all over u squared, and my uv is being replaced by 4uv minus 3uv, which is plus 4uv minus 3uv minus 12v what? Squared. Now you check. The last two signs again, minus plus will give you a minus, the visible. I don't mean the last term here, the last sign here. The visible signs you can see. Minus plus gives you what? Minus. So it's correct. Minus minus again gives you plus, which is also correct. So we can try to what? Combine. I will take these two as 1. u squared minus 2uv in brackets. If I bring my negative sign from here, it must come exactly as it is. All the signs here will change. instead of negative 3uv become 3uv, which is positive. And instead of positive 6v squared become negative what? 6v squared. You can check negative times invisible positive is negative, and negative negative is what? Positive. So again, So we have another question on the whiteboard rather. And we have a square minus open bracket b plus c close bracket square all over c square minus open bracket a minus b close bracket square. Now, if you look at this question very carefully, you see that it's same as saying a square minus b square all over a square minus b square, giving you a minus b and what? A plus b. So this is difference of two squares. Now, what we simply do here, we take here as our A and take here as our B. Take here also as our A and take here as our B. So we simply have A square minus a little open bracket B, A rather, minus open bracket B plus C in brackets, close bracket, another bracket A plus open bracket B plus C, close bracket, and use a square bracket. All over, because this is and this A minus B and A plus B are expressions. So again, we simply have, in place of A now, we have C. So we have C minus open bracket A minus B, then use a square bracket, another open square bracket, C, this time instead of negative become positive, bracket A minus B, close bracket, and close the square bracket. Now this gives me A. Minus times invisible plus gives you minus B. Minus times plus gives you what? Minus what? C. All over A. Plus times invisible plus gives you plus B. And plus times plus C gives you what? Plus C. All over the same process, C. Minus times invisible plus minus what? A. Minus times minus gives you what? Plus B. Close bracket again. Open bracket. This gives you what? C. Plus times invisible plus gives you plus A. Plus times minus gives you minus B. And this gives you A minus B minus C all over A plus B plus what? C. All over negative A plus B plus C all over A minus B plus C. So we look very carefully, nothing can cancel that. Let's cross check if we've made a mistake. Y is positive, here is negative. Y is negative, here is positive. And Y is negative, here is positive. If I put a negative sign at the top, I'll have negative negative in brackets A minus B minus C, bracket A plus B plus C, all over in brackets negative A plus B plus C, in brackets A minus B plus what? C. Now I use one of the negative sign to expand, or have negative brackets, negative times invisible positive gives you what? Negative A. Negative times positive gives you what? Negative times negative rather give you positive B, and negative times negative gives you what? Positive C. All over A plus B plus C, all over negative A plus B plus C, bracket A minus B plus what? C. Now you see this can cancel this, and I have negative bracket A plus B plus C all over A minus B plus C. And with this, nothing further can be done. Our next question. Okay. Let's assume this time we have we have 9a squared minus m squared all over m squared minus 2am minus 3a squared. So if we have this, the first thing we have to do is to try to express the numerator to give you difference of 2 squared. And we know that our 9 can be written as what? 3 squared. And we have our a squared minus m squared all over what? M squared minus. If we try to factorize the denominator, we simply see that 3 times invisible 1 will give me what? 3. And if I use 3 and 1, I can have 2. Because 1 minus 3 is equal to negative what? 2. So minus 2am can be written as what? Am minus positive am minus what? 3am minus what? 3a what? Square. Now, the top will give me what? 3a in bracket square. Because 3 square a square is same thing as 3a times what? 3a, which we have here, giving me what? 9a square. So this expression and this are the same in terms of what? Indices. So I have minus what? M square all over my m square plus what? Am in brackets. Remember, negative must equal positive. I'll bring this negative sign and put exactly. And since I have a negative sign in front of the bracket, my minus 3am becomes what? Positive 3am. And my negative 3a square becomes positive 3a what? Square. Now, this is difference of 2 square. This will simply give me 3a minus m. 3a, use the negative m. And also 3a, negative become positive m. And remember, if I expand this or come back to the exactly what? Question, the exactly expression of the numerator. Now, all over, here, m is common. So I have m bracket, m squared divided by m will give me what? M. And am divided by m will give me what? A. Negative sign. This is 3am, this is 3a squared. So our 3 is common and a is also what? Common. So 3am divided by what? 3a will give me what? M. And 3a squared divided by 3a will give me what? A. Again, the two brackets are what? Same at the denominator. And I'll therefore have what? 3a minus m in brackets 3a plus what? M. All over. Since the two brackets are same, I simply pick this combined with this to give me what? M minus what? 3a in brackets and m plus a. Pick one of them. Now we try to see if something can cancel out. Now, why here is positive 3a? Yes, negative 3a. And why here is negative m? You can see that this is what? Positive m. So we try to rearrange. So I can simply say negative m plus 3a in bracket 3a plus m all over this. You write it exactly the way it is. Since m comes first and followed by 3a. All over what? M plus what? A, which is this. Now, if I put two negative signs as the numerator, I've not changed anything. I'll have my negative m plus what? 3a in bracket 3a plus what? M. All over what? M minus what? 3a in bracket m plus what? A. Now, you use one of the negative signs to expand this expression so that it equals this expression. Or have negative bracket m times negative m will give me what? Positive m. And negative times positive 3a will give me what? Negative 3a in bracket 3a plus what? M. And you copy the denominator exactly as it is. And you can now see that this can cancel this. And our final answer becomes negative bracket 3a plus m all over m plus what? A. If you pick values for a and b, provided a and b does not equal 0, the value of a and b picked must not be equal 0. For it to be equal 0, if you pick m as 3 and you pick a as negative 3, you have 0. And 0 divided by any numerator will give an undivided fraction. So if you pick any two values for a and m, as long as denominators are not equal to 0, the expressions rather will give you an equal what? Value. So that's that. Let's move on to our next question. Let me write that side. So our next question is, let's assume this time we have 2a square m minus 3am square plus m cube all over am square minus 2a square m minus 3a cube, rather 2a cube. 2a square m minus 3am square plus m cube, all divided by am square minus a square m minus 2a cube. So we are still on our simplification. Now, having this as our solution, the first thing we have to observe is that this is not a quadratic expression. Neither is the button a quadratic expression. So what we simply do, we try to factor out. If you look, we have a here, we have a here, there's no a here. But we have m here, we have m square here, we have m cube here. So we pick the limiting variable, which is what? M. In this case, I'm focusing on m. If I put my m out, I will have what? 2a square left, because m have cancelled m from the 2a square m. And if I divide 2am square by m, I'll have 3a rather m. Plus, if I divide m cube by m, I'll have what? M square. All over, I'll do same here. What's common here is not m, but a. Because this is a square, this is m, but there's no a here. So a is what we have to be common. So if I bring a out, a divide am square will give me what? M square. And a divide a square m will give me what? Am. And a divide 2a cube will give me what? 2a square. Now we try to factorize the top expression in brackets and the bottom expression in brackets. Now this will give me m in brackets. Remember, even if it's not well arranged, those that carry square must be at the edge, since the middle term does not carry square. Take notes. Now, I'll simply have 2 times 1 will give me 2. And minus 2 minus 1 will give me minus 3. So I can have 2a square minus am minus 3 minus 2am plus what? M square. All divided by a bracket m square, this is am, and 2 times the coefficient of m square, which is coefficient of a square 2, which is negative 2 actually, and the coefficient of what? M square, which is 1, will give me what? 2. So I can simply say negative am plus 2am, which is minus 1 plus 2. Then minus 1 plus 2 gives you what? Positive 1. So it should be plus am minus what? 2am, because invisible 1 minus 2 will give me what? Negative 1. So plus am minus 2am is equivalent to minus am. I'll put my negative 2 what? A square. Now I'll have my m rather, in brackets. 2a square minus am will be grouped as 1, so I will use a square bracket. 2a square minus am. And again, check, plus times minus is what? Minus. You bring this negative sign exactly how it is, and I have my, since negative is at the outside, every sign here changes. So negative 2am will give me positive 2am, and positive m square will give me negative what? M square. Check, negative times positive will give me negative, 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 positive. So this will give me a rather, in square brackets, open brackets, m square plus what? Am in brackets, yeah, minus in brackets. Since negative sign is here, all these signs will change. Become 2am plus what? 2a what? Square. Negative invisible positive is negative, and negative positive is what? Negative. Now we have a in brackets. What's common here is what? A. A divide 2a square will give me 2a, and a divide am will give me what? M. minus what's common here is m. If I bring my m out, m divided 2am will give me 2a, and m square divided by m will give me what? M. You put your division sign again. This is m and this is a. Then what's common here is what? M square brackets. You have your m, which is common. M, which is common in brackets. M square divided by m will give you m, and am divided by m will give you what? A. You bring your negative sign. 2a square and 2am and 2a square. 2a is common. If I bring my 2am divided by 2a will give me m. Put my plus sign. 2a square divided by 2a will give me what? 2. Will give me what? A. And again, if you check, the two brackets are the same. And at the denominator also the two brackets are the same. It's a check to know if your factorization is truly what? Correct. So I have m in brackets, square bracket rather. You pick this and this as 1. So you have a minus m. A minus m. And you have what? 2a minus m. Close bracket. All over, you have your a at the denominator. You pick your m minus 2a. M minus 2a in brackets. And another bracket, the inner, which is what? Which are common. M plus what? A. Now, if you watch, this and this can be worked with. You can't use this. Why? Because y here is positive a, here is also positive a. And y here is negative m, here is positive m. Since these two does not work out, they are not different signs. Here is positive a, here is positive a. You can't do anything in common between these two. But this and this, you see that when here is positive 2a, here is negative 2a. And when here is negative m, here is positive m. So our focus is these two. 2a minus m and n minus what? 2a. So we rearrange to have m in brackets 2a minus m and another bracket a minus what? M. All over a bracket. I want to rearrange this to save time. This will give me negative what? 2a, positive what? M. In brackets m plus what? A. And now I'll put two negative signs. So negative m bracket 2a minus what? M. In bracket a minus m. All over a bracket negative 2a plus what? M. Bracket m plus what? A. This negative sign will multiply these brackets. You can't use it to multiply this and this at the same time. One negative sign is for one bracket. So we have negative m. I'm using one of the negative now to multiply. Negative and invisible positive 2a will give me negative 2a. And negative times negative will give me what? Positive what? M. In bracket a minus what? M. All over a in bracket negative 2a plus what? M. Bracket m plus what? A. So you see this can cancel this, and we simply have negative m in bracket a minus m close bracket all over what? A. I can rearrange this to give me what? A plus what? M. Now, you can choose to expand this if you choose to. This will give you what? This can simply give you negative, that's if you choose to, because we can simply end here. This will give you negative am plus what? M square all over a square minus what? Plus rather am, which is m square minus am all over what? A square plus what? Am, if you choose to. Okay. So we have 2m minus u in bracket square minus m minus 2u in bracket square all over 5m square minus 5u square. So solution. So you can simply see that the top is difference of 2 square, though is an expression, not just a term. What we simply do here, we have this as what? 2m minus u. And we'll put a negative sign. We have this m minus what? 2u. You must enclose it. And you also have 2m minus u. This time plus brackets m minus 2u, close brackets, all over. The denominator is way easy. Now we simply have 5 to be common. So we have 5 bracket what? M square minus what? U square. Now from this, we can try to make use of the negative sign to expand the right hand expression, giving you what? 2m minus u. Negative times invisible positive will give me negative m. And negative negative will give me positive what? 2u. Put your square brackets. Bracket again. This will give me 2m minus what? U. Positive times invisible positive will give me positive m. And positive and negative will give me negative what? 2u. All over 5. Again, this is difference of 2 square. So you simply have m minus u, bracket what? M plus what? U. Rearranging gives us 2m minus m minus u plus what? 2u. In brackets, 2m plus what? M minus u minus 2u. All over 5 brackets m minus u and m plus what? U. We've completely factorized the denominator. So therefore, we have to express the top, which is the numerator, if anything can cancel out at the denominator. Now, 2m minus m will give me what? M. And minus u plus 2u is simply minus 1 plus 2 to give me positive 1, which is plus what? U. And 2m plus m will give me what? 3m. I don't know if you understand this, but what's happening here is 2m plus m. This m carries an invisible 1. So if m is common, if I have my m out, I'll have 2 plus what? 2 plus what? 1. Because m divided 2m will give me 2. And m divided itself, m, give me what? 1. And I'll have m bracket 2 plus 1 giving me 3. And m times 3 gives me what? 3m. That's how we got this 3m. And minus u minus 2 is just like minus 1 minus 2. Anything it gives you, attach your u to it. Will give you minus what? 3 what? U. All over 5 brackets m minus u and what? M plus what? U. Now you can simply see that m is common here. I can factor it out. So this becomes 3 brackets m plus u brackets m minus what? U. All over 5 brackets m minus u brackets m plus u. First, m plus u can cancel m plus u. And I'll have 3 brackets what? M minus u. All over what? 5 brackets was m minus u. So this can simply cancel this, and our final answer gives us what? 3 over what? 5. So we have a bracket b plus c, close brackets, plus b plus c, close bracket, square, all over b square minus c square plus ab minus ac. So having this, we can realize that this square is a repeated root. So starting with that, we simply have a bracket b plus what? C. Plus b plus c, b plus what? C. All over this, you should be careful on how you try to like combine. But we can see that plus times minus is already the minus here. So we'll use it the way it is. This will give you what? B square minus C square in brackets. You bring your plus exactly how it is. And the signs inside remain the same. Why? Because when there is a plus sign, everything inside remains the same when you expand. Plus times invisible plus is plus, and plus times minus is what? Minus. Now, you focus at the top. A bracket B plus C is a term on its own. B plus C and B plus C is another term of its own. So what you simply do, you pick out what's common, which is B plus C. If I have B plus C here, if I use that B plus C to divide A bracket B plus C, I'll have A here. And if I use this to divide B plus C and B plus C, I'll have B plus C left. You can put it in bracket, but if I use positive to expand the bracket, it will still give me what? B plus C. But it was negative, I must write the negative to expand so that the signs inside will change. And this is difference of two square. So I'll simply have what? Here I'll simply have B minus C and B plus C. I'll put my big plus sign to know that they are different. And for this, A is common. I'll have A bracket what? B minus what? C. The same way we did the top that we factor out what's common, that's how we are going to do the bottom. Because we can see we have B plus C, B minus C, and B minus C. So the top remain B plus C. Don't make the mistake of using this to cancel this, but because they are not, this and this are not here. So you don't need to use this to cancel this. So you have B plus C bracket, A plus B plus what? C. All over what? What's common here is B minus C. So you bring B minus C out. If B minus C is divided B minus C and B plus C, you have what? B plus C left. Since here is plus, I can simply put my plus. And B plus C dividing A bracket B minus C will give me what? A left. And from this will give me B plus C in brackets, bracket A plus B plus C, all over what? B minus C. B plus C plus A is same as A plus B plus C because addition is cumulative. If I have 3 plus 2 plus 4, this is same as what? 4 plus 2 plus 3, and it's same as what? 3 plus what? 4 plus 2. All equates to what? 9. So this bottom can be rearranged to give me A plus what? B plus what? C. And you see, this can cancel this, and our final answer becomes B plus C all over B minus what? C. So let's assume we have A squared plus B squared all over A plus B. Since this is positive, you can simply see it's not difference of two squares. And this is already on its own. So this expression cannot be simplified further. Or you can simply say it cannot be simplified to simpler what? Forms. And if we have s squared plus xy all over s squared minus y squared. What we simply do here is to factor what's common at the numerator and at the denominator. This will simply give me x. X cancelling s squared is x, and s cancelling xy is what? Y. And this simply difference of two squares is s minus y and what? S plus what? Y. And this can cancel this, and our final answer is x all over what? X minus what? Y. So let's take maybe the second to last in terms of simplification of algebraic fraction. If we have b squared plus ac minus ab minus bc all over c squared minus ac plus ab minus bc. How can we simplify this? we can simply see that these two, they don't have any term in common. But these two does. These two do rather. So we can have b squared minus what? AB plus AC minus BC. All over again, you check. Plus times minus is what? Minus here. This will give you what? C squared minus AC plus AB minus BC. So I didn't alter this. And plus times minus is what? Minus. The next is for us to do our grouping. So we have b squared minus what? Bring your plus sign the way it is. And you have your what? AC minus what? BC. Since we have a positive sign, the signs remain what? The same. All over C squared minus AC in brackets plus what? AB minus what? BC. Plus sign is here. Plus sign is invisible, plus is plus, and plus times minus is what? Minus. So B is common. I can bring my B at B squared divided by B is B. And AB divided by B is what? A. Plus. What's common here is C. C brackets. AC divided by C will give me what? A. And BC divided by C will give me what? B. All divided by, what's common here is what? C. C squared divided by C is C. Minus AC divided by C is what? A. Plus. What's common here is what? B. AB divided by B is what? A. And BC divided by C by B is what? C. Now, if you watch this is a critical question. Because while here is positive B, here is negative B. And when here is negative A, here is positive A. And at the bottom, while here is negative what? Positive C, here is negative C. And when here is negative A, here is what? Positive what? A. So we have to do something. Now we simply have B bracket B minus what? A plus. This plus now, if I change it to minus, then all the inner value, the sign must be changed. When I have positive A here, it becomes negative A. And when I have negative B, it becomes positive what? B. The same thing goes to the bottom. C bracket C minus A. Why here is positive? If I change it to negative, I will have all the bracket, the signs must be changed. Positive A become negative what? A. And negative C become positive what? C. Now we can rearrange the inner brackets. This is B bracket B minus A minus C. I can rearrange this to give me what? Positive B minus A. It didn't cause any equality sign, so the signs remain the same. And positive B, since B is the first term in this bracket, I can simply remove the negative sign to avoid confusion. All over C bracket C minus A minus B bracket what? Again, C minus what? A. Even if you put plus, it's the same thing. But I want it to be exact as this. Now you simply have equal expression at the top in the bracket, equal expression at the bottom in the bracket. So I'll pick this and this as 1, B minus C. And I'll take one of the brackets since they are the same, B minus A. All over C minus what? B. All over C minus what? A. So I've reached here. But if you observe now, why here is B minus C, this is C minus B. I can rearrange these two, this bottom, to suit it. So I can have minus C plus B. Can I use that? This is BC, this is BC, yes, I can use that. This is BC and this is what? CB. So I have negative C plus B in brackets, bracket B minus A, all over what? C minus B, bracket C minus what? A. Now, why here's negative C, here's what? Positive what? C. Why here's positive B, here's negative C. Remember when I rearrange, I didn't change the signs, the negative and the positive sign. Because it's only when it crosses an equation and there's no equation sign here, it remains what? The same. So I have this and this. I'll put two negative signs. This will give me negative c plus what? B, all over b minus what? A, and c minus what? B, bracket c minus what? A. Now you use one of the negative sign to expand this bracket. I'll have one left, and negative will give me positive c, negative will give me what? Negative what? B, bracket b minus A, all over c minus B and c minus A. And this can simply cancel this, and I'll have my final answer to be negative bracket b minus A, all over what? C minus what? A. We can't rearrange this in any form, any other form. Why? Because we can simply see that these two alphabets are not the same. But a student can simply go further to say, use the negative sign to multiply the denominator so that A can come to the front. Or you can also use it to multiply the numerator so that A can be at the front, whichever way. If you are using this to multiply this, you have negative B plus what? A, all over C minus what? A, giving you A minus B, all over what? This will give you C minus what? A, because it's better positive number comes equal negative number. So this is correct, this is equally, this is not, this is equally what? Correct, because positive must come before what? Negative. So let's assume this is a question. You can do this on your own. If we have A minus B all over B minus A, and these are options, so do it to choose the right answer. Solve and choose the right answer. So let's move to the next subtopic here. Multiplication and division of algebraic fraction. So we are supposed to continue multiplication and division of algebraic fraction now, but we'll do that in our next class. Thank you. And do everything possible to like, share, and subscribe. Thanks, everyone.